I've been asked by one of my viewers to go into a little bit of detail on this Marconi 2019 signal generator. He's a bit confused about some of the controls and like a run through of what they do. I'm not going to go into all the second function controls. I might have a quick flick through the manual I've got here to explain a few things, but I'm just going to go through the basic operation of the unit. It's not that intuitive, I must admit. It took me a little while to get used to because nothing's particularly clearly laid out. But basically what you've got on the left hand side here, you've got the frequency readout, which is, as you can see, up to 162 kilohertz at the moment. Your modulation mode and your percentage of modulation is on the center channel, on the center display. And on your right hand display here, this is your RF level, or output level if you like. Now, it's fairly straightforward to use once you've got the hang of it, but it does take, as I say, a little bit of getting used to. This is the output jack here. Obviously, this is an N-type connector. I've adapted to a BNC because I don't run into the high megahertz. I only run up to 150, 160 megahertz maximum, and I run it through this adapter thing that's used to be a detector, but I've got a serious capacitor inside to just give a bit more protection to the front end of the set if it gets DC on it. It does have reverse power protection. Reverse power protection means basically if there's a DC level on the output jack, it will activate a protection circuit and flash this RF power level, this RF level switch to indicate it's had a DC signal. It drops the output and you have to manually reset it by pressing the button again. As you can see, that a lot of the markings are fairly worn on this. I bought this as a Spiers repair machine. As you can see from some of my previous videos, I had a leaky capacitor and did a bit of damage to the board. But so what I'll do is I'll start from the very basics. There is a degree of programming. You can actually program these machines or units to come on with a default power on setting. Normally they start at 1080 megahertz, top end of the frequency, which I really can't see the point of that doing. But what I've had mine set to is if you switch mine on, it will default to 10.7 megahertz, as you can see there, which is obviously the FMIF frequency. So basically what I'll do is I'll run through. I mean, I don't use this a huge amount, so just bear with me on a couple of things if I get stuck or confused, but I will try and do my best to explain how it works. We enter our frequency with a numerical keypad or an up and down control here. This is the down arrow, and this one here is the up arrow. So if I want to, for example, if I want to enter 100 kilohertz, I will enter 100. I don't have to press anything else, and I select kilohertz here, which is this button here. There we go, 100 kilohertz. So that's our frequency defined. We've set that, and I want to an AM modulation. So I select AM. So you press AM. This now knows that we're working on modulation because I've gone to AM mode. So anything I type in here will be relative to modulation. So I'll go 100. 10% or 45%. 45% modulation. So the modulation is now set, and last of all is the RF output level. So then I press RF level, which is the bottom key, and then I just select the RF level 100 millivolts, and if you heard that click, that's the output relay turning on. Or I can select minus 20 dB, and it will read out in dB. Output is still on. If I want to turn the RF level off or turn the output off of the generator, I just press the on-off button here, the relay. Or likewise, if in carrier frequency, I can still turn the output on and off. Whichever mode that's in, it will turn it on and off. If I'm in FM or AM, if I'm in the modulation mode and I press the on-off button, all that will do is turn the modulation off. The carrier will remain in the previous state. So that's fairly straightforward, that. You've got other options here for store and recall, and basically you enter a setup you want, and then you press store, and then you press the store button you want, and it will store it in non-volatile memory. And you recall that by pressing recall and the memory button, and it will recall it back. It's just a simple storage procedure that you get with a lot of these bits of test equipment. It's just a it's ideal for setups like the 10.7 megs. You probably want 75% deviation on FM if you're doing an FM strip or something like that, or maybe 108 megahertz with 75% modulation. You know, you can store that in preset 2 and just recall it rather than having to type it all in. I tend not to use that. I think I've got one set up there. Let me just remember if I can do it. Recall 1. There you go, 460 kilohertz. Recall 2. No, I've got nothing in recall. So it's just recall 1. I have 460 kilohertz for AM, IF. 70% modulation on AM. And then, so if you're in the frequency range and you want to go up frequency and down frequency, you could just press the up and down keys. And if you want to know how far you've deviated from your original frequency, if you press the total button, that will give you the 6 kilohertz shift from your original frequency. So that's quite a useful feature. Never use it, to be honest with you, but I mean it would be useful if you were sort of setting frequency markers or something like that, maybe. You can also set the deviation on the how far it shifts up and down. Now you have to bear with me with this. So if this is shifting up at 1 kilohertz steps, I think if I press the percent deviation 10. Let's see, this is where I can't remember how we do this. So we need to go carrier frequency and then go 10 kilohertz. Now, if I turn that off, however I do that, I think it will go up in 10 kilohertz steps now. There you go. So all that does is it shifts the amount of percentage change when you press the up and down key. 10 kilohertz is a bit too steep, really, for that sort of in the AM band. 470 kilohertz, you need it in 1 kilohertz steps. But basically, that's what all that does. Let me give you a quick demonstration of the modulation. It's got an internal frequency generator, and it will also generate. You can feed in an external signal through the external jack here and modulate the source. So let's go to 95 megahertz on this tuner. So we type in carrier frequency 95 megahertz, RF level 100 millivolts, and then put it on FM. And there we see we've got the carrier, we've got the signal strength, we've got no modulation at the moment because the modulation is actually on AM, so you won't hear anything on AM. That's useful if you were checking the AM rejection of a tuner. You can hear it just about breaking through. So I'll go FM. There you go. That's 100% deviation, which is too high for FM, so we'll drop it to 75%. Kilohertz, sorry, 75 kilohertz could be deviating an FM signal. And then you've got the internal tones. So you've got 3 kilohertz, 6 kilohertz, 300 hertz, 400 hertz, and 1 kilohertz. So pretty straightforward. In that mode, this switch here, the mod ALC, is modulation automatic level control, is permanently engaged. If you want to modulate from an external source, you're in FM mode still. You need to make sure you're in modulation mode, and then you go internal external, and that will feed you any signal being fed into this jack here. Let's plug it into the Panasonic. I'm feeding a tone. Let's get this right, make sure I'm doing this right. I'm feeding in a tone, external, what am I doing wrong? There we go. So I'm feeding in a tone, and now the ALC control is enableable. You can actually enable the automatic level control to try and maintain the right deviation on the modulation. So that's how that works. It's pretty straightforward. And then as I said earlier, there's some secondary functions as well. Also, another point to make on the internal and external, if you're in carrier frequency mode and you press external, it will look for an external standard, which I'm not running at the moment. It's running, I think there's a link at the back telling it the external standard's not connected, but you can feed in your own reference frequency and it will use it won't use its internal oven and frequency standard for a reference. However, these are pretty good actually. This one seems to be very, very stable at frequencies, so that's not really a problem. So that's how that works, really. Just a quick flick through the instruction book. It's fairly well laid out, and it's fairly clear, and it does go into sort of quite a lot of detail on how everything works. It has GPIB interface as well, as you can see here, and it's got sort of like block diagrams at the back to show you how it all works. So it's the manual's pretty worth getting. If you can get a manual, it's pretty worth getting. There are manuals available online that should be downloadable free. I think certainly found the service manual for it. I'll go into so I can find the special functions for you, but I'll try and hold this up so you can actually, if there's anything you want to read here, you can just freeze frame and just try and get it all in the shot. But it's quite a highly spec'd machine, this, and it's probably actually easier to use than the Hewlett-Packard's equivalent that I've also got. This is all GPIB control and stuff, which I'm not using. This is all the stuff on how it increments, control the increments, external modulation switch. This is this second function unlock, and this is more the sort of more advanced settings that you wouldn't want a normal operator to get hold of. But this is how that works. You press second function 0 modulation, and then you get into these higher levels of control. And some of those include the setting I had for the default power on frequency. You can change all that sort of thing. A lot of this stuff I don't understand because it's all GPIB control, and I've never ever used that, obviously. But it's most of the last pages here, as you can see, all GPIB. But there are other controls, but to be honest with you, no one's going to really use them. Certainly in a facility like this, when you're just using it as a fixed signal generator for checking radios and things.